Okay, so I had some requests for the question about the rectangle on page 15. I believe it's number 11. So it says a rectangle measures 72 by 108. So you can see here I've gone out and drawn my rectangle. Obviously not to scale, but sometimes drawing it out might help you. So 72 would be you put on the long or the shorter side, and then 108 on the longer. A 2 by 2 centimeter square could be used to cover the rectangle without any spaces or overlapping, and explain why. Okay, so that really, we're just going to do this in pieces. So a 2 by 2 centimeter square can be used to cover the rectangle without any spaces. Well, really, this is where your divisibility rules are going to come into play. Okay, so you should be thinking about prime numbers and divisibility rules, and that should help you immensely. So you know that this ends in a 2, you know that it's going to be divisible by 2. You know this ends in an 8, yes, it's going to be divisible by 2 again. So obviously, yes, then we can use that 2 centimeter square. And I'm sorry, you're going to hear Tucker whining because he doesn't like that I put him in his pen. Okay, it says, how can you use the common factors of 72 and 108 to identify all the squares that can be used to cover the rectangle? So to do that, we need to list the common factors. Now, unfortunately, Google Slides is not conducive to making a factor tree. So I have just listed my factors. Most of you prefer prime factorization and factor trees. I do too. And I have to admit that when I did this, I actually did a factor tree on my note paper. So if that's going to help you, do that. But when I did my prime factorization, this is what I got. So once you've got that, then you move on to the next step. And the next step is to create a Venn diagram. And you remember that I showed you this in the book, and I said, if this doesn't work for you, don't do it. However, if you're really struggling with this question, this is where you need the Venn diagram. So I've listed all my factors. Now, the ones in the middle are the ones that are the same between the two. If there's any left over, like for example, 72 has an extra 2 that 108 doesn't have, and 108 has an extra 3 that 72 doesn't have. Everything else goes in the middle. So you put them in the middle like this. Common prime factors in the overlap. Then you multiply the common factors to determine other factors of the numbers. However, the question says that this is a square we're doing, and we have to find other squares. So the two numbers have to be the same. So when we list out our common factors, 3 times 2 times 3 is 1, but that's not a square. And 3 times 2 is 1, but it's also not a square. So immediately I eliminate a good portion of mine. So once I've done that, then I start looking at, okay, anything that wouldn't form a square can't be the correct number. So the greatest common factor, the GCF, and you're going to see that on the test, GCF, greatest common factor, is 3 times 3, which is 9. So if you made it harder than that, I'm sorry. It's easier. So then it says list all other squares with the whole number dimensions that can be used to cover the rectangle. Well, we've eliminated the ones that can't be used because we're making a square. So we're only left with one factor. And there's only other one square, and the dimension has to be 2 by 2.